the lights, you can. All right. So 2.3, the two learning targets we're going to focus on today are I can divide polynomials using long division and rewrite as a product and a remainder. Product plus remainder. That'd be quotient? I don't know. I can divide polynomials by synthetic division and determine when it's appropriate to use synthetic division, and I can also rewrite the depressed polynomial and remainder. Okay. We will talk about what a depressed polynomial is. It doesn't mean it's sad. Okay. You can divide polynomials by using either long or synthetic division when appropriate. The process of dividing polynomials using long division is similar to that in arithmetic, with the alternating of dividing, multiplying, and subtracting. Dividing, multiplying, subtracting. Okay, to set up long division for polynomials, be sure the dividend is in standard form. Both actually, the divisor and the dividend need to be in standard form. And you will need placeholders for any missing terms. That means if it has an x cubed and then an x, you need to put a 0x squared in there to hold that spot. Synthetic division is a shortcut for long division, and it only works when the divisor is a linear constant like this, x minus 3, x plus 2, okay? Yeah, did I not just read that to you in smaller print? Okay, well, that was special. All right, so I don't know if you have this problem. You certainly don't need to do it if you don't want to. I'm just reviewing the process with some numbers instead of letters, okay? So when you do this, you usually look at this first term to figure out how many times it goes into this first set here. Now, we're pretty good at this, so I would say 1 goes into 5 times, but I don't think 13 times 5 is going to go in, right? 13 times 5 is not going to go into 54, so I think we have to round down to like 4 times. Okay, that was kind of dividing in our head, right, to figure out how many times we thought it would go in there. Then the next step is we multiply. 13 times 4 is actually 52. Then the next step is that we subtract. And then we bring this guy down. And then we look again. 13 goes into 26. Well, we're pretty good at that one, is exactly 2 times. Then we multiply. 13 times 2 is 26. We subtract. We get down, we get 0, but we do have to bring this 7 down. 13 doesn't go into 7, so this is a remainder. Now, there's 2 ways you can write that remainder. When we were first learning this, the teacher just had us write R7, right? But does anybody remember eventually how you might have written that? As a fraction? Jada, do you remember? Yes, this goes over the divisor out here, so it is 7/13. Does anybody remember that part? Okay, so this is, and it's actually added on there. When it's a polynomial, we want to put plus. Here you wouldn't need it, but it is remainder over divisor. Okay, what else do I need to point out? I thought there was something else I wanted to talk about. Oh, if we were to check this problem, I don't know if you remember this, you would do 42 times 13, and then after you did that, you'd add the 7 back on, and it should get this, let me see how fast I can do this, 6, 12, placeholder, 2, 4, 546 plus 7 is 5. What did I do wrong? 42 times 13. 6, 12. Did I miss? Oh, yeah, I think it should be 5. This should have a 0 before we put the divisor. Thank you, thank you, thank you. Wow. I can't even do it algebraically. How am I ever going to do it? Okay, so this, we said this goes in here 0 times, so then we needed a remainder of 7/13. Wow. Great video, Hofbauer. All right. So this would have had a 0. This would have had another 0. When we add a 7, we'd get 5, 4, 6, 7, which checks. Okay. That was a hot mess. I'm really sorry. Yes? Okay, now you're really confused because I was confusing. All right, you can just watch this one because it's all done for you right here, okay? So let me just talk you through it. So it said up here, I'm going to start with the problem up here, all right? So it said to take 3x cubed minus 2x minus 4 and divide it by x plus 1. That means the x plus 1 is the divisor out here. The dividend is 3x cubed, but there's no x squared in this term, so I need a placeholder. I'm going to put a 0x squared there. Then it has a minus 2x and a minus 4. Then I look only at this first term, guys. So x, what do I need to multiply to make it exactly 3x cubed? I need to multiply it by a 3 and 2 x's, right? So then I have to distribute this to both of these terms out here. So 3x squared times x is 3x cubed. 3x squared times 1 is 3x squared. Now, the next step is where students get messed up, is you are subtracting this quantity. What I usually do is I actually like to use 2 different colors, but I change it to add and change the signs on both of these, because then I'm adding and my sign changes is more clear. This is 0. This adds to negative 3x squared. I can bring down the minus 2x. Now again, I'm looking at the first term up here has to become exactly this term. So I need to multiply by a negative, a 3, and an x. So that when I multiply it by this x, I get exactly negative 3x squared. Then I'm also multiplying this by the 1, so I get a minus 3x. Okay, then I'm subtracting, which is the same as adding the opposite. Change the signs, and now I'm adding. This is a 1x, bring down the minus 4. I look at the first term right here. To become exactly this first term right here, I would just need to multiply by 1, which would give me a 1x plus 1. When I distributed that to both of those terms, then I'm subtracting or adding the opposite. Now I'm adding a negative 4, negative 1 is a negative 5. So the remainder is plus negative 5 over the divisor of x plus 1. Yes? No? Look a little familiar? Okay. We're going to try one together. Oh, yeah, I'm going to skip this slide for a minute. We'll talk about synthetic division in a minute. I will come back. Okay, you can't use synthetic division for this problem because of this coefficient of 2 out front. Okay? So even though it's a linear term, we're going to need the long division. So what goes inside the box, guys? The first one, right? The dividend, or what we are dividing into. Do we need any zeros on this one? All right, and out here goes the 2x minus 1. Antoine, you awake? Okay. All right. If you want me to talk through it, and then I'll give you a second to write it down, or you can write it down as we go, try it on your own, whatever you're thinking here. We look at the first terms only, and we need it to multiply to be exactly this, not the opposite sign, but exactly this. So 2x times what will become a 2x cubed? x squared, good job. And then I distribute that to both of these terms out here, this binomial. So 2x times x squared is 2x cubed. And that x squared times that negative 1 is a negative 1x squared. Then I'm supposed to subtract that quantity. I'm going to change it to add the opposite so that I don't mess up the second sign there. That's the one I always mess up. And now when I add the opposite, this is 0, which it had better be or we did something wrong. And this term back here, I got a 4x squared. And then I bring down a minus 8x. All right, now I'm looking at the first term out there. To get this first term down here, I need to multiply 2x by what to become 4x squared? A positive 2 and an x. All right, so 2x times 2x minus 1 would be 4x squared, and 2x times that minus 1 at the back by there would be minus 2x. Then I am, again, subtracting this quantity or adding the opposite, which will become what? Good job, a negative 6x, and then I bring down this plus 3. And what do I need to multiply 2x by up here to become a negative 6x? A negative 3, and I'm distributing it to both of those. So I get a negative 6x, and then negative 3 times that negative 1 is a plus 3. Now, some of you will recognize right away that that's no remainder, but we're subtracting this quantity or adding the opposite, which is a 0x plus 0. So this one came out even with no remainder. Now, if we wanted to check this problem, you would do this x squared plus 2x minus 3 times the quantity 2x minus 1, okay? And you'd have to distribute it all out, collect like terms, and it should go back to this. That doesn't sound very fun to me. All right. Number 2 looks a little more miserable. Outside here, I have an x squared plus 3x minus 4. Inside, do I need any placeholders as I go here? I don't think so, right? I have a degree 3, 2, 1, and no x's, so I have 2x cubed plus 5x squared minus 7x plus 6. You try the first set on your own. X squared needs to become exactly 2x cubed. So it needs to multiply it by a 2 and just 1x, right? But now I have to distribute that 2x to all 3 of these terms out here. Two x times 3x would be a plus 6x squared. And 2x times that minus 4 would be a minus 8x. Then you are subtracting. Again, my suggestion is that you change it to add the opposite and change all the signs. Anybody figure out what that would be for this next little step right here? Yep, a negative 1x squared plus 1x, and then bring down that 6. Okay, be careful because sign mistakes will kill you here. What are we going to do next? We want this x squared to be exactly a negative 1x squared, so we got to multiply it all by negative 1. All of this multiplied by a negative 1 will be a negative 1x squared, a minus 3x, and a plus 4. Then if we are subtracting all of that, we are adding the opposite. So this is 0, 1x plus 3x is 4x, and 6 minus 4 is plus 2. So how are we going to write a, can I multiply an x squared and make it a 4x? No. So how am I going to write that remainder? Anybody get that fraction business? I put plus, and what goes over what? The 4x plus 2 goes over, that's mess, x squared plus 3x minus 4. So if I were to check this, I would have an x squared plus 3x minus 4 times a 2x minus 1, and then I would need to add the remainder. Okay, and it should get back to what I started with. I can do it real fast if you want. I wouldn't bother to write it down if I were you, but it's up to you. So I got a 2x cubed, a 6x squared minus 1x squared would be a 5x squared. A negative 8x minus 3x is negative 11, plus 4 would be negative 7. And there was a 4 plus a 2. Okay, so it does, when you multiply divisor by quotient and add the remainder, you do get back to the dividend. All right, that was my check. All right, ooh, what's happening here? Yeah, you have an x squared plus 8. Now you could put a plus 0x in there. It's not as important when it's the divisor. Maybe I'll write it there just to help some of you. Under here, I don't think we need any placeholders. Do we have an x to the 4th, 3x cubed, 4x squared, 24x minus 32. All right. This is the last one we're doing together today for long division. Okay. X squared to become x to the 4th, you would need to multiply by x squared. But now we have to distribute that out here. So x squared times x squared is an x to the 4th. X squared times 0x would still be 0, right? If you want to write it here as a 0x cubed, or you just skip that spot because it's 0. And then x squared times 8 would be a plus 8x squared. Now, if we subtract all that, or add the opposite, this is 0. This is 0, so we just bring down the 3x cubed. 4x squared minus 8x squared is a negative 4x squared. And I'm probably going to need to bring down the 24x back here. What am I going to multiply by next? I need 3x cubed out of an x squared, so it needs to multiply by a 3 and an x. So I'm distributing that to all of this. 3x times x squared is 3x cubed. 3x times 0x is 0x squareds. You don't really need to write that, but it's not going to change anything. Okay, and then 3x times 8 is a plus 24x. If I subtract or add and change the signs, do I have nothing? I have to bring this guy down, right? This is a negative 4x squared, but this is 0 back here. But then I have this negative 32 to bring down from up top. And I think it's going to be nice, yes, because to get an x squared to become exactly negative 4x squared, I need to multiply by negative 4. And negative 4 times x squared, you could put that there's 0 x's, but negative 4 times 8 is negative 32. If you change to plus the opposite, we just get no remainder. Did someone else get that? So this was our quotient. Do you need help with that vocabulary? Quotient is the answer. After we've divided, okay? The one in the box is the dividend. That's what's being divided. And then what's dividing into it is the divisor. Anybody's struggling with that vocabulary? Okay, I'm going to go back and do the synthetic division. Now, I think it might be the same problem here. We had this original problem, 3x cubed minus 2x minus 4 divided by x plus 1. This is a problem because this is a linear term with a coefficient of 1. So it's just x plus or minus something. You could have done this one by synthetic division. Can you remember that in a second, what we got when we divided? What you would do is you would take this 3x cubed minus 2x minus 4 divided by x plus 1. Okay, this is the mistake students make most often, is you put the 0 in this box. So x plus 1 becomes a negative 1 here. Then you put the coefficients across the top. This one had a 3x cubed, a 0x squared, a negative 2x, and a negative 4. Okay? So it says write the value of c in the box, the coefficients of the dividend in the first row, and insert a placeholder if needed. Okay? Then it says you bring down the first one. And then from there on, it's multiply, add, multiply, add. So negative 1 times 3 is negative 3. You add and get negative 3. Negative 1 times negative 3 is positive 3. Negative 2 plus 3 is 1. Negative 1 times 1 is negative 1. You add and get negative 5. Use your calculator if you're not good with signed numbers, okay? Now, the last term is your remainder. So we have a remainder of negative 5. We were dividing by, x plus 1. So that's down here. Then going back, after you cut off the remainder, this is a constant. This one gets an x, and this one gets an x squared. So I have a 3x squared minus 3x plus 1. Which I hope is what we got here, right? 3x squared minus 3x plus 1 with a remainder of negative 5. Everybody okay? All right, so let's go to the top of the next page. Again, this says you write the related 0 in the box. So if we're dividing by an x minus 3, you put a positive 3 here, then all of your coefficients, and then it's bring down the first one, multiply, add, multiply, add, multiply, add. And the power of the first term is 1 less than the degree of the dividend, etc. I just always start back. Okay. Oh, tricky one from the beginning. What goes in the box? On the top left. the 0 of this, which would be -4. Everybody okay? Then I need all the coefficients, but what's missing here? A 0x squared. So my coefficients are going to be 1x cubed, 0x squared, -28x's, and a -48. And this last one is going to be my remainder. All right, do you need time? First one just drops down. And then it's multiply, add, but what am I multiplying? -4 times 1, okay? -4 times 1 is -4. 0 plus -4 is -4. -4 times -4 is, this is what I'm multiplying by, is this guy up here. -4 times -4 is 16. -28 plus 16 is -12. -4 times -12 is +48, which is 0. So there's no remainder, but what does this mean the divisor is? Well, start at the back and it's a constant. The next one, that -4, gets an x, and the 1 gets an x squared. You can leave the 1 out there if you want. Try the next one. We need a 0 again, don't we? Placeholder, we have a 0 x's. So 1x to the 4th. Oh, we need 2 zeros. There's also a 0x cubed. Wow. 0x to the 3rd. -3x squared, 0x, and 12. Well, the good news is all that goes in the box is what? Yeah, the 0 of this is just 1. I don't know why this messes students up so bad, but be really careful, because when you have a 0, somehow students get all confused. 1 times 1 is, but 0 plus 1 is 1. 1 times 1 is, -3 plus 1 is, 1 times -2 is, 0 plus -2 is, and 1 times -2 is, so what's our remainder? 10. Good job. Okay, so our remainder is 10, which if we're writing it as a polynomial goes over, it says, write as your quotient polynomial plus remainder over divisor. So they want it written as a fraction, not just R10. So it goes over, the divisor, remember, was really an x minus 1. Okay, then I have all this. The -2 at the back is a constant. The -2 in front of that gets an x. Then I have a 1x squared and a 1x cubed. Yes? Remember this? Comfortable with this? Synthetic isn't bad. Long division can be miserable because one little mistake and it all goes bad, right? All right, so your practice is in Delta Math. It's called 2.2/2.3 because we're going to finish up a few ideas from 2.2, and then it has like 3 or 4 long division problems. I don't think it really has much practice on synthetic division tonight that I can remember.